All right. Hello, scientists, and welcome to another day of outdoor school. My name is Pika, and I will be your outdoor school instructor for today. So I'm looking forward to working with you so that we can all learn about Streamflow. That's today's lesson, is on Streamflow. So hopefully you've heard of Streamflow before, and if not, that's totally fine. We're going to be learning about it together and kind of some of the things that Streamflow impacts, both in the ecosystem and for us human beings. So before we get started, I wanted to begin with a question of the day, something kind of similar and related to Streamflow. What's the craziest storm that you've been in? So while you're thinking about that question, I'll tell you about the craziest storm I've ever been in. So I live here in Utah, which is a couple states over from Oregon. And I vividly remember being in a snowstorm that dumped 2 feet of snow on us in 24 hours. So this was a crazy storm. It totally canceled school for a couple of days. And I remember digging tunnels and digging snow forts through the snow, and my mom telling me that it was dangerous to be in that snow fort because I probably didn't construct it very well. So that was definitely the craziest storm that I've ever been in. So think about a storm you've been in, and today we're going to learn a little bit about streamflow, and storms absolutely impact streamflow. So we'll talk a little bit about that too. All right, so let's start by having a few questions that hopefully we can answer by the end of our lesson today. So the questions of the day are, first of all, what is streamflow? So we'll hopefully answer that in the next few slides in a little bit as to what streamflow actually is. Then let's ask, how do changes in streamflow affect other components of an ecosystem? So those other components could be things like plants, animals, rocks. There's lots of other components of an ecosystem that are impacted by streamflow. And then how do changes in streamflow affect people? So people every day are impacted by streamflow, and we're going to learn a little bit about why. So we want to start by acknowledging that here at Outdoor School and at any outdoor school location in the Portland area, we are on the traditional territories of several indigenous tribes and groups. So both the Multnomah Education Service District and Outdoor Schools are on the traditional territory of the Clackamas, Molalla, Cascades, and Kalapuya peoples, and many of those groups are now part of what are called the Confederated Tribes of the Grand Ronde and the Confederated Tribes of the Warm Springs. Also, outdoor school locations sit on the traditional homelands of the Wasco, Wishram, Claflamet, Clatsop, Lower Chinook, Wahkiakum, and Willapa nations. And those today are known collectively as the Chinook Nation. So we just want to acknowledge that we are on that land of those traditional territories. Additionally, since we're on the topic of water today, let's consider why water, and rivers specifically, might be important to the indigenous people of this region. So think about this question on the slide. Why might rivers be important to the indigenous people of the Columbia River? So you should be thinking about that. Why is water and rivers important to anybody, but especially the indigenous people of this region? And there's a hint on the slide in the picture that might give you an idea. So hopefully now you have it. It's salmon. Salmon are a very important part of the culture of many of the tribal nations in the Pacific Northwest, especially here in the Portland area. So let's read this quote from the Columbia River Intertribal Fish Commission that talks about why salmon is important to the culture of tribes in the Pacific Northwest. So, salmon have long been the symbol and lifeblood of the people who call the Pacific Northwest home. Columbia Basin salmon play an important role in the ecosystem of the region, returning ocean nutrients to the rivers and streams where they were born, feeding wildlife, and even feeding the forests with their bodies. For thousands of years, salmon also shaped the lives of the people who have lived here since time immemorial, which means since as long as people can remember. The cultures, intertribal interactions, fishing technologies, and the very religions of the Pacific Northwest tribes were all impacted and influenced by salmon. These fish have even been an important part of the economies of the region for thousands of years, and from the ancient Indian trade routes all the way to modern commercial fishing. So many indigenous groups, in fact, all indigenous groups in the area we are, have fishing rights, tribal fishing rights. So there were many treaties negotiated in the 1850s that forced the tribes of the Columbia River Basin to give up millions of acres of their land. And in exchange, these tribes were given significantly smaller parcels of land, which you might know as reservations, and the right to continue fishing in some capacity. So today, the tribes of this area have full commercial fishing access above the Bonneville Dam, which is a dam near Portland, and everywhere upstream by about 147 miles from that dam. So currently the tribal nations have full commercial fishing access in that area above the Bonneville Dam, and indigenous people are continuing to fight to protect their fishing rights even today. They do that by being involved in fish hatchery management. They do that through protests in something called fish-ins, which is a form of protest, and through legal challenges in the courts. So a federal court decision in 1974 finally affirmed that the tribes are actually guaranteed 50% of the harvestable salmon from the Columbia River Basin, or from the Columbia River itself. So tribal fishing rights are very important and sort of an ongoing effort among the tribes to protect those fishing rights. So there is still considerable work to be done to protect tribal fishing rights along the Columbia River because there are many anthropogenic, which means human-caused, factors that are limiting salmon populations and therefore the ability of indigenous people to harvest those salmon as they have the right to do with their tribal fishing rights. So some of those factors that are limiting salmon populations are overfishing by other groups, habitat alteration, pollution, and dams. So dams are a big one. There are 14 dams on the main stem of the Columbia River and over 450 dams in the Columbia River Basin, which means all the tributaries that flow into the Columbia River. So in 2016, a tribal nation called the Yakima Nation, which is in southern Washington, just across the Columbia River from us, helped gather funding and support to remove a dam on the White Salmon River, which is a tributary of the Columbia River. So what we're going to do is watch a video of this dam being removed. And what I want you to do as we watch the video is see if you can notice how the river changed immediately after the dam is obliterated. You're going to see a dam be blown up. And then think about how that river probably changed over the next 5 or 10 years after that dam was removed as well. So be thinking about those questions and enjoy the video. All right, hopefully you heard the explosion there. Now see if you can notice anything about the water coming out of this dam. What does it look like? What color is it? Does it look like it has anything in it? How is the river below this dam changing immediately as a result of this dam obliteration? Now in a sec, we're going to see a shot of the lake above the dam. Here it is, and how it's changing. You'll see now the water level is dropping above the dam. The banks are being exposed. There's some people watching this happen. Wouldn't that have been fun to be there when this happened? Just so you know, this is probably within 50 miles of Portland, just on the northern side of the Columbia River. Here's some final shots of what it looked like above and then below the dam. Okay, so hopefully you noticed some changes that immediately happened to the river, right? So a lot of sediment came out of the bottom of the dam, first of all, and that's because there was a lot of sediment trapped behind the dam, and then it all came rushing out at once. So that's kind of why the water was murky. That probably had an immediate impact on the stream below, might have made the water quality different for just a short period of time. And then we also wanted you to think about some longer term changes that probably happened to the river. So I was fortunate enough to go to this location just last year in actually 2 years ago in 2019. So about 3 or 4 years after it happened. And I got to meet someone from the Yakima Nation who was involved in this project. And she talked about how they replanted lots of vegetation of native plants along the stream banks after this dam was obliterated. And that restabilized those banks. And eventually the sediment did sort out and the water started clearing up. And within 5 or 10 years, that river is going to look a lot closer to how it did before the dam was there. So the whole purpose of this was to help return salmon to that tributary, to their native spawning grounds, to improve the population of salmon and to return the river to its normal state. So that brings us into our lesson for today, which is stream flow. So let's start by asking the obvious question, what is stream flow? So stream flow usually refers to the amount of water that's flowing in streams, rivers, and other channels, and it's a major element of the water cycle. So if you've learned about the water cycle, you know that it involves evaporation and eventually precipitation, and streams and rivers are a big piece of that cycle. They convey water down to the open bodies of water like lakes and oceans, where evaporation then occurs again. And so streams and rivers are a big part of the water cycle. And stream flow is just a measurement of how much water is flowing in those streams, rivers, and other channels. It can be measured as the amount of water that's moving past a certain point in a given amount of time. So that's how we measure stream flow. So to get into some of the more specific details of how we measure stream flow, this picture here should help. So first of all, people who measure stream flow are called hydrologists. You probably recognize the word hydro from within that word, meaning water. And so these are people who measure stream flow and other characteristics of rivers. Now you'll see here on the cross section that there is several chunks of the river that are being measured. And this is how scientists measure stream flow. So part of what they do, now I'll get the pointer out here. So you have different subsections of the river that are measured. And what they'll do is they'll measure the area of each of these subsections. So the depth times the width gives you the area of one subsection. And then for that subsection, you can also measure the velocity of the water, so how quickly the water within that subsection is moving. And if you times the velocity by the area, if you multiply those two things, it gives you the discharge. So how much area of water is moving in a given amount of time. And then if you do that for each of these subsections and add them all up, you get the total discharge of the river or the stream flow of the river. How much water is moving past a certain point in a given number of time. So the next question that this begs is, does stream flow ever change? If we can measure stream flow at one period of time, is it always about the same or does it change? Well, as you probably are expecting, stream flow changes all the time. So first of all, this is a picture showing an area that looks pretty normal on the left side, but then within 1 hour is completely flooded on the right. So why might that be? Think about some reasons as to why the stream flow might have changed so much and so drastically in this picture. So you might be thinking that there was some sort of large storm or precipitation event that caused this to happen, and that would absolutely be right. So depending on the size of precipitation events or storms, stream flow can go up very quickly. It can also change on seasonal cycles, just as there's snow melt feeding the rivers or more storms in the spring. All those things change stream flow. And hydrologists keep records of the flow or the stream flow in a river over time. And those records are called hydrographs. So if you're interested, you can look up a hydrograph for a river that you know and care about to see how the stream flow changes over time. So all this begs another question: how do those changes in stream flow, of the stream level going up and down and faster and slower, how do those changes affect other components of the ecosystem? So things like plants, animals, rocks, terrain, the landscape itself, how are those changed by changes in stream flow? Well, let's start by talking about just living organisms, plants and animals that live in and around streams. So as stream flow changes, in what ways do you think that affects the animal life and the plant life that depend on those rivers for survival? How do changes in stream flow impact the plants and animals? So changes in stream flow have a big impact on aquatic organisms, especially organisms like fish. So for example, salmon, which we talked a little bit about earlier, have to swim up rivers from the ocean to spawn, which means lay their eggs. And they need there to be enough water in the streams, a high enough stream flow, that they can reach their prime spawning grounds and lay those eggs. So that's definitely a way that stream flow impacts that organism. But just as stream flow affects plants and animals, how do you think plants and animals affect stream flow? Are there any ways that that relationship goes in the other direction? So how do you think plants and or animals affect how much water is in a stream or flowing in a stream? So the picture here, once again, gives you a little bit of a hint. What animal do you think was primarily responsible for what we see in this picture on the right? Well, you probably are thinking beaver. So the beaver is responsible. So first of all, animals like beavers change the structure of rivers by creating pools and slowing the river down. So this beaver has created a beaver dam here, and that has slowed the river down, which changed the stream flow. It changed the amount of water moving past a given point in a given amount of time, which is the definition of stream flow. So animals definitely impact stream flow, just like the stream flow impacts them. In fact, while we're on that topic, beavers are actually called or referred to by some people as ecosystem engineers because they have such a big impact on the ecosystem through their construction of dams. So another way organisms impact stream flow is vegetation. So plants that grow along stream banks actually stabilize those stream banks with their roots, and that makes it so that the channels of rivers stay more consistent instead of meandering as much. So the vegetation growing along rivers can actually make streams stick to a more consistent channel. So as we've seen with these examples, living organisms also impact stream flow just like stream flow impacts them. So rivers and stream flow can also impact the rocks and terrain, the non-living components of an ecosystem as well. So how might the stream flow of a river affect the sizes and shapes of rocks along the river bottom? What are your ideas? So you might be thinking about a time when you were along a river and noticed that the rocks were super, super smooth, whether in the river or just outside on the banks. So part of the reason why this happens is when stream flow is higher, when there's a more amount of water moving more quickly in a river, that can really bounce the rocks along the bottom and polish them and make them smoother. So the amount of river water there is and how quickly it's moving has an influence on the sizes and the shapes of rocks. On a bigger scale, rivers actually can also impact the terrain of the landscape, not just the rocks in the river, but the rocks and surrounding terrain of an entire area. So how might the changes of a river affect the landscape and the terrain of an area? So you might be thinking of some different rivers you've seen. I'm thinking of rivers here in Utah. In fact, just south of Utah in Arizona is the Grand Canyon, which was formed by a river. Rivers over time can cut down through rock and form canyons. And so that's definitely a way that rivers and stream flow impacts the terrain. And also geological uplift. So the plates of Earth are always moving and uplift is sometimes occurring, which is what forms mountain ranges. And as rivers are flowing across the landscape while uplift is happening, they can actually sort of cut down through the landscape and form canyons. So that's another way that rivers can form and translate and change the terrain around us. Another way, which you'll see here in this picture, is by forming river deltas. So as rivers come out of the mountains where they're moving quickly and then come out into valleys, they slow down. And as they do that, all the sediment that is suspended in the rivers begins to drop out and settle down to the bottom because the water isn't moving as fast anymore. And so as this happens, the sediment is deposited out into these large deltas, sometimes called alluvial fans. They look like little fans. And as it fans out and releases that sediment, it creates these deltas that provide great habitat for birds and for other aquatic organisms. And deltas actually can help humans too. So they form natural barriers between the ocean or large bodies of water and cities, or coastal cities at least, that are on the other side of deltas. And that way, when storms happen out in the ocean or large bodies of water, there's a natural barrier that can protect the cities. So deltas impact and help human beings too. So that kind of leads us to our last question of our lesson. That's, how do changes in streamflow affect people? So streamflow affects people every day. And so speaking of storms, let's have a quick brainstorm session. What are some of the ways that the amount of water in a stream or a river, so the stream flow, might impact people? So go ahead and think, what are some ways that stream flow, or the amount of water in a river and how fast it's moving, how might that impact people? So to understand how changes in stream flow impact people, it's helpful to talk about two extremes of stream flow. So the first one is flooding. So when there's more water than what you would normally have in a river. And the other extreme is drought, when there's significantly less water available in rivers or less stream flow. So thinking about those two extremes of stream flow can help us think of how stream flow impacts people every day. So let's start with flooding. What are some of the factors that determine how severe a flood will be, how negative or big of an impact it's going to have on people? So you should be thinking of some different things that might impact how severe a flood would be. The first one might be kind of obvious, but how much total precipitation is there or is occurring? That has a big impact on the size and severity of floods. So precipitation comes in many forms. There are large precipitation events of rainfall that can cause flooding. But even large amounts of snowfall can cause flooding if all that snow in the mountains melts at once. So sometimes flooding occurs because you'll have a very warm spell during the spring that releases lots of meltwater from melting snow. So how much total precipitation there is one factor that influences how severe flooding can be. Another factor that influences how severe floods are is something called infiltration. So infiltration is the process of water soaking into the ground. When infiltration occurs quickly, there's less water remaining above ground to cause a flood. But sometimes water cannot soak into the ground quickly, such as when it is on things like roads or cement sidewalks or other man-made structures that make it difficult for the water to infiltrate. So this leaves the water standing above ground, therefore causing a flood. So how quickly infiltration occurs is one of the ways that determines how severe a flood is going to be. If there's not a lot of infiltration, the flood could be worse. And finally, this one's a little trickier to think about, but how severe a flood is actually also kind of depends on where people are located within the floodplain, because we're the ones who sort of determine whether a flood is severe or not, for us at least. So where people are located within the floodplain definitely influences how severe a flood is. So for example, when people build their homes within a floodplain, and a floodplain, just so you know, is an area adjacent to a river or a body of water that frequently floods. So that could happen once every 10 years or 100 years, but it's the area adjacent to a river or body of water that does flood sometimes. And this just happens naturally in and around rivers. Floods do happen. So how severe a flood is in terms of our perception depends on if we've built our homes in places or other places where we are next to floodplains. So you could probably guess which house in this picture would be more severely impacted by a flood. You might see that there's one right along the bank there on that picture on the right, and then some further up on the bank. So the ones that are closer to the edge of waterways are going to be more severely impacted. So where people are located within the floodplain influences how severe that flood is going to be felt by them. So what are some other ways that people are impacted by flooding? Well, it's important to know floods are one of the most common disasters in the United States and among the most deadly. So you might think, well, floods don't happen that often, but they actually happen all the time, and they are a very big deal for people. So knowing things about streamflow and how streamflow changes definitely is important for people. Additionally, flooding is now going up and increasing more because of climate change. So humans, as we know, are burning fossil fuels, which is warming the climate. And as the climate warms, the number and the severity of floods is starting to increase. So we're getting more large precipitation events that cause flooding, and this is increasing as the climate warms. So we might be seeing more floods all the time. Luckily, there's going to be some things we can do at the end of this presentation to address some of these things. So don't worry about it too much. We just wanted to highlight this for right now. So the other side of the extreme coin of streamflow, right? We have flooding. That's one extreme form of streamflow. And then another extreme is droughts. So let's also think of some factors that determine how severe a drought will be. So give you a sec to think, what are some factors that determine how severe a drought will be? What are some things that make droughts bad, or make droughts even happen? That's another way to think about this question. So one is similar to with floods. How much precipitation is occurring? If you don't have a lot of precipitation, there probably won't be enough water to sustain things that people or even ecosystems normally need, and that can cause a drought to happen. So just like with floods, the amount of precipitation that is occurring in an area influences the severity of droughts. Obviously, when there's no rain, droughts can occur. And droughts can also occur when there isn't much snowfall on the mountains too, for the same reason that we talked about with floods. If there's not much snow, there's not much meltwater to then supply us with drinking water, agricultural water, and other things that we rely on in terms of water. So how much precipitation is occurring is one factor that determines how severe a drought will be. Another factor is how much water is available in storage. So what are some places in Earth where water is stored? What do you think? Other than just in a water bottle sitting on your desk or in a tank somewhere, what are some natural places water is stored in? So you might be thinking of the words aquifer or groundwater, and that'd be absolutely right. So if there's a lot of water available in those places where water is stored, then we have more to draw on to help us in times of drought. So a drought is less severe if we have water available in storage. But when droughts go on for a long period of time, or if we're just extracting a lot of water from the ground, from aquifers and groundwater, then there's less available water during times of drought, and we might feel those things more severely. So how much water is available in storage definitely influences how severe a drought will be. And finally, how much water are we using in the first place? That's another factor that determines how severe a drought will be. So when we use a ton of water, or if we use water irresponsibly, so maybe we're trying to grow plants in a place that's really hard to grow plants, like in the middle of the desert, then that can use up a lot of water, leaving less available for weathering droughts. So the amount of water we use and how wisely we use that water influences how severely we're going to feel the effects of things like droughts. So how are people impacted by droughts when they do happen? Well, you can probably think of a few things. Agriculture, there's less water available for growing food. Drinking water, there's less available water for us to drink, which we obviously need to drink to survive. Cooling is kind of an odd one, but if you think about it, if there's less water available in pipes to flow into our air conditioning units in buildings or homes, or swamp coolers, which is what I have here in Utah, where it's dry, those things help us stay cool, especially when it's hot like it is during a time of drought. So if there's less water available during droughts, then it's going to be harder to cool down buildings. And then another one is forests. So what might be a way that there being less water available for forests would cause some not so great impacts for humans? So if forests are drying up and they have less water available because it's a drought, what might that cause to happen? So you're probably looking at this picture and saying, I've seen the sky look like that before. In Oregon, maybe, because I know that's happened there recently. It's definitely happened in Utah. Wildfires. So when the forests dry up, it's more easy to ignite a fire, and fires can be larger and more severe. So droughts impact the severity of fires, which then we feel as people who live near forests and people who breathe in the air from forest fires. So that's another way people are impacted by drought, is by extension, they're impacted from wildfires. It's also important to know that just like with flooding, climate change is actually leading to more severe droughts too. So even though some areas are receiving more crazy precipitation events because of climate change, other areas are actually receiving a lot less water too. And so that's making droughts more severe in some places. So as I promised, I know some of this last stuff is a little scary to think about, but luckily there's a lot of things that we can do to address some of these things and prepare for a future with climate change, as well as just in general be more resilient. So let's start by talking about, for flooding, what are some things we can do about it? So first of all, we can build smart. We can build our homes, our buildings, our parks, everything that we need for a functioning society can be built in a way that keeps in mind that floods happen. So whether that's being careful about building in floodplains, if you do build in a floodplain, have flood insurance, build in ways that are going to be resistant to flooding when it does happen. Those are forward-looking things that we can do as a society to help us be ready for floods. Another thing is to just do something about climate change, right? If we find ways to reduce our carbon emissions and reduce the warming of the climate that's happening, that can help reduce climate change and, by extension, some of the impacts that we're going to see from climate change on flooding. In terms of droughts and things we can do about that, well, some of these are pretty similar, but a big one first is conserve water. So that means be smart with the water that we do use and use it well. So this could be using less water, maybe, not having as much water for growing lawns and instead using that water for drinking water. And there's a lot of ways to do that. But I'm going to leave that one more open because part of what you're going to do for your field work is look into some ways that water can be conserved. Another one is just like with with the location we build things and how that matters for being ready for floods. Similar thing we can do for droughts. So we can avoid building homes or growing food in places that are very likely to be impacted by drought. So this is not to say that we shouldn't expand or grow at all in places that are drier, but being more careful and thinking carefully about where we are building things and where the areas are that are more likely to be impacted by droughts, so that we're not putting a lot of people in harm's way. And then we can reduce carbon emissions, just like with flooding. We can reduce carbon emissions to reduce the impacts of climate change so that less of these severe droughts occur. So that's another way in the long run we can be addressing these things, is by thinking of ways to address climate change and reduce our carbon emissions. So hopefully you've learned something today about, first of all, Streamflow and what it is, how it impacts ecosystems, so plants, animals, and even non-living things like rocks and terrain. And finally, how Streamflow, especially the extreme ends of Streamflow, impacts people every single day. So what we're going to do to carry on our knowledge and apply it for our field work is we're going to calculate our household water use. So step one is going to be going to this website, watercalculator.org, and there's going to be several questions that you can answer about your household water use. It's going to spit out a number of how many gallons per day your household uses, and then you're going to compare that, if you'd like to, as kind of a bonus. You can compare that to the average daily water use of an average person in Oregon, which is 113 gallons per day. That might sound like a lot, so hopefully you're in for some surprises with this activity. One note quickly there is, if you calculate your household water use, that's going to be higher than the individual person water use of Oregon that I put on this slide. So if you'd like, you can divide your household water use by the number of people in your household, and that'll tell you your per person water use, which you can then compare to the average for Oregon. But mostly you're just calculating your household water use for step one. Step two is brainstorm 5 ways that you can conserve water. So you can do some research on the internet if you would like to come up with some ways that are more applicable to you. You could talk to your friends or your family members and ask if they know of any ways that you can conserve water in your household. So that's step 2, is brainstorm 5 ways to conserve water. And then step 3 is answer some questions about this in your field study notebook. So starting on page 10, I believe, 11, there are several blank lines for the water field study, and you can write your answers to these questions, as well as the answers to the previous 2 as well. And so the questions I want you to answer are: what surprised you about your household water use? When it comes to conserving water in your household, what areas do you do well on, and what areas could you improve on? And then finally, what were some of the best water conservation tips that you found in your research? So again, just to summarize, you're going to calculate your household water use using the link watercalculator.org. You're going to brainstorm 5 ways to conserve water. And then you're going to end by answering some questions about that research that you did. So what surprised you about your water use, and what areas could you improve on? What areas are you already doing good on? And what are some of the best ways you could envision conserving water in your household? All right, so hopefully you learned something today about Streamflow and how it impacts ourselves and other things. And enjoy your field work, and we'll look forward to hearing your answers to those questions next time. All right, thanks everybody, and see you soon.